Today we're going to take a look at lesson 4.1 from Math and Focus in our 6th grade textbook, where we are working with comparing two quantities. And we're working in our ratio unit. So we've taken some good notes on lesson 4.1. The problem is they didn't show us a lot of conversions. So I'm going to spend some time to go through these problems kind of one by one with you, just so that you're kind of prepared for how that might look. And we're going to really try to tackle those things in class together, because again, it's not maybe expected that you have mastery of those conversions, but just that you're kind of familiar with them at this point. All right, taking a look here, it says for the first section, we want to write a ratio to compare the quantities. Number one, if Jacob buys 17 ounces of grapes and Olivia buys 21 ounces of oranges, they give me this bar model. And down below it says part A, what is the ratio of the weight of grapes to the weight of oranges? Oh, I noticed we're comparing grapes to oranges. So if I were to take the grapes first in my ratio, I could look up at that bar model and see 17 represents the grapes. Next, the weight of the oranges comes from this bottom bar. Looks like 21 ounces. And I can just show a comparison, maybe using a colon. Also remember, we could use the word to. You could maybe even write it as a fraction. However, we try to save the fraction more often for when we know we're comparing a part to the whole. So maybe I was talking about all of this together. All right, let's look at number one, part B. What is the ratio of the weight of oranges to the weight of grapes? Well, you might think that you've already done that, but in reality, they've changed the order on you. Order matters when we're talking about ratio. So I noticed they want oranges first this time compared to grapes. So oranges come first. Looks like I'm going to use that 21 for my first term. And the grapes come next. 17 would be next. Notice I could probably write this as 21 to 17 using word form. And this would also be an okay answer. Notice order matters. The first thing that they ask for becomes my first term. The second thing that they request becomes the second term. Next, we're going to move ahead here, and we're going to state whether these can be expressed as ratios. So let's see if I can scroll us that direction. Sorry, because I have to move to my computer to get that to work. So here we go. If you take a look, we're given a couple of examples. So we're supposed to state whether this example can be expressed as a ratio. So that's really the question. Can it be expressed as a ratio? And if yes, I'm going to want to write that ratio in simplest form. I'm going to want to simplify when I'm done. So I asked my students to think about today, what type of units are we measuring? Well, we have some different choices, right? We could think about some measurements help us measure length. Some measurements help us measure mass or weight. And other measures can help us with volume. So as long as the units I'm given have to do with the same type of measure, I know that I can write them as a ratio. So taking a look here, 2 yards. Well, let's think, what do yards measure? Oh, if I was measuring yards on a football field, I'm talking about the length. That's a length. So I'm going to write length above here just to see what we're comparing. Notice it says now I have 60 inches. Well, if I'm measuring inches on maybe a picture or a picture frame, or inches from one side of the table to another, I'm again talking about length. This checks out. Length compared to length. I can do that in ratios. I can compare the same type of units. Now here's the challenge. They gave me yards, which we know are quite long, and they gave me inches, which are relatively small. These are not the same size units, but because they measure the same type of thing, I'm going to use conversions to get there. So let's see if I can find some information to help us out. This same idea, the same conversion table, something similar at least, might be found in your planner on page R8. So that's the reference pages, page R8. So I'm just grabbing the information that has to do with linear units or length. It might talk about length there. If I took my yards, right here I see 1 yard, it's the same as how many inches? 36. So if I had 2 yards, I would really need to multiply that times 36. So it'd be 36 inches in each of those yards. So I'm going to double that amount and see what I get. Now notice these inches are already in inch form, I can leave them alone. So if I were to do a rewrite step, 36 times 2 gets me, let's think here, 30 and 30 is 60, and 6 and 6 is 12 more. Sounds like I'm going to get 72. And the 60 gets to stay the same. It is okay to write this as a ratio because we're able to make them both inches. And once those units match, we no longer have to label them inches and inches. Now this won't be a final answer because if you remember back in the problem, they asked me to simplify, to show this ratio in simplest form. So we want to think of the largest number, the greatest common factor that divides into 72 and 60. And if you look at your multiplication chart perhaps, or you think back, 12 will work. Well, 12 goes into 72 6 times, and 12 goes into 60 5 times. So notice I'm keeping my first term lined up with my first term, my second term lined up with my second term. My final answer here is a ratio of 6 to 5. All right, well that was possible because I had the same types of units. They were both measuring length. Let's see what we have with this next one. So I don't think I'm going to need this piece of my conversion chart any longer. Let's compare number 3. Here they give me gallons compared to tons. Well, if I break up my conversion table on page R8 of your planner this year, or if maybe I look up online, I want to figure out what gallons help me measure. So if you do some looking, you're going to find that gallons are going to be listed underneath American capacity. They're talking about capacity or how much something might hold. Oh, that's a volume situation. So I'm going to write volume up above this gallons. And I'm going to compare that to tons. So I don't see tons on my American capacity grid here. I don't see that as part of this volume conversion. So let's see what else I can find. Do a little more digging on that page R8 if you can. And you might find that tons show up underneath weight and mass. So tons have to do with how much something might weigh or the mass of an object. So I'm going to write down right above the word tons that has to do with weight. Or I could write mass here, but this is the same idea for today. It's enough for me to see that these two units do not measure the same type of thing, do they? In fact, volume and weight are very different. And I'll never be able to convert my gallons to tons or my tons to gallons. It's not possible. So, no ratio possible. It is impossible to write a ratio for these two quantities. They don't match because they don't measure the same type of units. We're going to move on here. We're going to work on numbers 4 through 5 next, where they're asking me to complete to express each ratio in simplest form. So looking right here, I notice we have the same sort of problem. For the first problem, they gave me feet and yards. The good news is they're showing me that they're going to be equivalent to feet and feet. They're asking me to change my yards to a smaller unit, to feet. Well, you could grab that conversion chart again, page R8 of your planner perhaps, or maybe you look it up online, or maybe you see inside your notes, I left you a little spot where on page 1 where you might be able to find this information. How many yards are in 1 foot? Well, if we look here, I said that wrong. How many feet are in 1 yard? If we look right here in this middle section of our table, it says that 3 feet belong in 1 yard. So I'm going to have to take my feet and multiply them by 3. They're going to be more smaller units inside, more feet inside of my yards. So let's go ahead and simplify, see what we get. 5 times 3 is 15, but do be careful. This is sitting here with the second term of my ratio. So it needs to still line up with the second term in my equivalent ratio. This 18 feet, it's already in feet form. I can leave it alone. It was the first term. It's still the first term. And if you look at the very end here, they say this is still equivalent to something more, meaning they took off the labels because feet and feet match. We don't need those labels anymore. And all we need to do is put this in simplest form. So let's divide by the greatest common factor of 18 and 15. Well, they're not both even, so 2 won't work. But 3 seems like a good possibility. I know 3 goes into 18 and into 15. 3 goes into 18 6 times, and notice because I'm dividing my first term, I record that as the first term in my equivalent ratio. Because 3 goes into 15 5 times, I record that as the second term of my ratio. And this is the final answer. They're looking for 6 to 5. Please remember, order matters. If for some reason you switch the order and you got 5 to 6, you technically have a mathematical lie happening. We want to be careful about that. All right, let's take a look at number 5. And hopefully you're noticing there's a problem here. I have ounces compared to pints. And we don't really use these units a whole lot, probably, unless you're really big on cooking or I can't think of why else you would need those things. So if I take a look over here, I need to find a conversion that's going to help me out. I'm looking for ounces and pints. Well, that sounds like capacity to me. Sounds like I'm comparing how much something might hold or its volume. So let's see if we can find a way to change, if you look, pints to ounces. That's what they're encouraging me to do. Well, this chart is really awesome because it shows you right here that inside 1 pint, I'll find 16 ounces. I do believe that in your planner, it talks about 1 pint being 2 cups, and that each cup then is 8 ounces. So you have to do a little more multiplying than what this one shows. But we're going to take this idea of pints because they're the bigger measure, and we're going to break them down. We're going to get more small pieces or more smaller units, or more ounces in this case. I need to actually multiply this by 16 because there are 16 ounces in every single little pint. All right, so if you take a look here, we're going to have to be careful about our placement again. Have I changed this first term at all? No. I still have ounces, 30 ounces. That can stay the same. But have I changed my second term? Yes, I had to convert pints to ounces. And I know 3 times 10 is 30. 3 times 6 is 18 more. Looks like I'm going to get 48 ounces. Notice my units match. Check, check. Almost like I can take those units right away now. And I'm ready to do the last step, which is to simplify. What could we nicely divide into 30 and 48? Try to think of the biggest common factor, the greatest common factor. 2 would work, but there might be something larger. 3? Oh yeah, 3 goes into both of them. Anything bigger than 3. 4 will work for 48, but not for 30. 5 works for 30, but not for 48. How about 6? It looks like 6 might divide into both these numbers nicely. Let's see if that might be my greatest common factor. See if it will work. So the first term is 30 divided by 6. That will get me 5 in the first position. And 48 divided by 6, if you check your charts, or if you remember 6 times 8 is 48, 8 will work for the second term. Is this in simplest form? If not, you could always simplify again. But if you take a look, this actually works. Final answer, 5 to 8. This next section is very similar, but they don't quite use the same layout for us, do they? So let's take a look at this next, where we need to write each ratio in simplest form. Now on your homework, I wrote a quick little note to you saying you need the same units first. So before I can write a ratio without its labels, I need to find the same size units. Well, number 6, I don't have to worry about no units, which means this 54 and 96 are ready to be simplified. What could I divide into both of these terms nicely? Well, if you check your charts, maybe moving across, let's see what we could find. Looks to me like I might be able to divide both of these by 6. I know 6 goes into 54 9 times. And I know 6 goes into 96. I could kind of write this as a number bond. It's like saying, let's see here, 60 plus 36. 6 goes into 60 10 times, and 6 goes into 36 6 times. So it looks like I'll get 16. Just double check that. Let's see, 6 times 10 is 60. 6 times 6 is 36 more. Yep, 60 plus 36 is 96. Here's my new improved ratio. Now the real question is it in simplest form? Did it work, or can I go a little bit farther? Well, 9 divides by not much. It might divide by 3 or 9, but those factors don't nicely work into 16. So this is a final answer. Now this is where it gets a little more complex, because if you look at the next problem, number 7 over here, they give me yards, which we know are quite large, and feet, which are relatively small. These do not match. What they do is they both measure length. So I know I need to trade in my information here from page R8 or from another source where you can just quickly find conversion charts. That's what I searched online, conversion charts, and find something that has to do with length or linear units. Well, if I take a look, I know I could take this larger unit of yards and turn it into feet. But I'm going to have to go to my chart and figure out how many feet are in a yard. Oh, that's right. There are 3 feet in every yard. So it's like saying 3 in the first yard, 3 in the second yard, 3 in the third yard, and keep on going. It's really like multiplying my yards times 3 feet in each. Well, if I were to go ahead and multiply here, 8 times 3 is actually 24. And that 40, it's already in feet, so I can leave it alone and take off my labels. But it's not a final answer because if you remember, they asked us a minute ago to simplify. We want to divide 24 and 40 by a common factor. So what goes into both? 2 is nice, but we're at the option now. 4, going once, going twice. No, outbid by 8. It looks like 8 will go into both. Let's give that a try and see what we get. It's okay to use an equal sign now because we're writing an equivalent ratio, and I'm kind of running out of space to move down this page. So 8 goes into 24 3 times, and 8 goes into 45 times. Notice I'm paying attention to the order, and I'm giving you a final answer, 3 to 5. All right, number 8. Boy, wouldn't it be nice just to simplify this, but we can't. We can't just simplify because we have some units that don't match. I have gallons compared to pints. And if you remember back a minute ago, gallons and pints don't have the same size units. So I'm going to see if I can find us a chart that will help. Page R8 of your planner might be a good help. Oh, this is tons and pounds, not useful. Oh, look underneath capacity. The section that talks about capacity has both gallons and pints on it. So it might say liquid measure, or in this case it says American capacity. How could I change my gallons and my pints to match? Well, if you take a look here, I see something on this chart that's really helpful. It tells me that 1 gallon is the same as 8 pints. If I were to take those gallons and pour them off into 8 groups, or into groups of 8 pints each, I'd get quite a few of them, wouldn't I? It's saying there are smaller units, many of them hidden inside these gallons. So I'm going to take the 4 gallons and multiply by 8, and that's going to get me 32. Those are currently pints, and that's what I'm trying to get to. I'm trying to turn all of these into pints so they match. And next I have 20 pints, which can stay the same. This is not a final answer because we can't forget to simplify. So we're going to think of the greatest number, the greatest common factor that divides into both. So whatever rule I use for one of my terms in my ratio, I must use for the other. It's just like fraction rules. So 2 goes into both. I can see that working. Not 3. How about 4? Does 4 divide into 32 and will it divide into 20? Is 4 a good choice? I think 4 might work. Let's try it. 4 goes into 32 8 times because 8 times 4 is 32, and 4 goes into 25 times. Can you simplify any more? No, indeed, this is a final answer. For this last one, I love to challenge students to find out how much they weighed when they were born. This kind of helps them think about pounds and ounces, and something that they probably care a little bit about. So I'm not sure I see pounds and ounces on here. Doesn't look like that's a capacity sort of a situation. So I'm going to see if I can find us the conversion that might be more helpful. Oh, pounds and ounces. They're talking about how much you weighed when you were little, right? So maybe you were 8 pounds, 5 ounces. Maybe you were 7 pounds, 12 ounces. We kind of want to make this a little more meaningful to you. So if you can think of pounds and ounces and how they're kind of related, that would be a great investigation. Talk to your families about it. Well, I'm going to take a quick look here, and I know that ounces are pretty tiny compared to pounds. So what I need to do is get these to be the same size units. Well, I was lucky enough to find a conversion chart that shows me right here. It says 1 pound is the same as 16 ounces. And I believe you will find that exact same conversion on page R8 of your planner. Well, what that means is I take the larger unit, and I know that there would be 16 little tiny ounces inside each of those pounds. So I can take those 5 pounds times 16 ounces and see what I get. Well, this 42 won't need to change at all. It's already in ounces. But 16 times 5, that will change. I'm going to get a larger number. 5 times 10 is 50, and 5 times 6 is 30 more. 50 and 30 makes 80. 42 to 80, we're now comparing ounces to ounces, so I can take off the units if I choose to. And I have to remember to simplify a little bit. So trying to think of something that divides nicely into 42 and 80. Check your charts maybe. Let's see here. 2, they're both even. Well, what about 4? 4 goes into 80, but not nicely into 42. Oh, 6 goes into 42. Does it go into 80? That's interesting. Well, 6 goes into 8 once, and there'd be 20 left over. I don't think 6 will work. Is there anything else? Well, let's start with that too, because I'm feeling a little bit stuck, and see where we get. What's half of 42? Well, half of 40 is 20, and half of 2 is 1. 21. And what's half of 80? 40. You do want to check. Can you simplify any more than this? Is there anything else that goes into 21 and 40 nicely? And the answer is no. I'm looking at a final answer. So for this page, the real challenge was finding me like units. They asked me earlier on if they were measuring similar things, and then once I know that they are, for instance, they're both measuring capacity, or in this case, they're both measuring weight or mass, I can find similar units, and I can then simplify my ratio. I think we're going to stop here for this lesson, for lesson 4.1. We are going to look at the word problems next time in a follow-up video.